Hello. Hello, everyone. Thanks for coming to API Conf Lagos 2025. API Conference Lagos. That's too low. API Conference Lagos. Okay, much better. So today I'll be talking about caching strategies for high traffic APIs. So a little bit about me. My name is Nelson Isioma. I'm a senior software engineer at Upfront Cloud. I'm also an open source contributor. I contribute to Traffic Load Balancer. I maintain Lemon Squeezy Laravel. So it's a Laravel package where you can easily add subscriptions, sell courses, etc. And then I organize PHPS Lagos. It's a community where you can meet other PHP developers because I'm a huge PHP fan. I write other languages, but I love PHP. And then I also write, I mentor, and I love dogs. I love golden retrievers in most course there. We have dog lovers in the house. Yeah, so what we'll be covering in this talk is, first off, I'll give a quick intro on what caching is, and then I'll tell you why you should cache, and then caching backends, and then how to host these caching backends, and then I will now go deep dive into these caching strategies. Then at the end of the session, we'll have a Q&A. So if you have any questions, you can just write them down and we'll discuss them after. So first off, let's start on definition. So there are a lot of pronunciations flying around, but the actual pronunciation is caching. Oh, it's not catching, it's not caching. Yeah, so caching. Yes. So what is caching? Caching is the process of storing frequently accessed data in a fast temporary storage layer to reduce response times and minimize repeated load on the CPU or database during API requests. So before you add a caching system, because caching is not free, it increases complexity, it increases cost. So there are a couple of things you have to consider on, do I really need a caching system? So the first thing is response times, if it's reducing response times for your application, a business priority. So if you are working on legacy software and some other domains, you might not really need to reduce response time. Most times, the correctness, accuracy of the data is much more important. But then if you are working in like fintech, gaming, real-time systems, reducing response times is very important. And then you have to consider caching if you have a particularly slow application. Then second thing to consider is, are your queries slow or just unoptimized? So let's say you have API endpoints and that the SQL query is taking 1 second. While you can cache that, there's probably something wrong if one SQL query is taking that long. So in that scenario, what you could do, I'll be talking mainly if you're using SQL databases. So what you have to do in those cases is probably selecting just the needed columns, adding proper indexes, and then on the infra side, I would suggest placing your app server and your database server in the same region. Because just having your app server on, let's say, US East 1, and then your database on EU Central can add, worst case, 100 milliseconds of complexity. Then some other reasons why you should cache is, let's say you have a read-heavy application, so you have metrics monitoring on your API, and you'll see that there are a lot more reads than writes, and these reads are for the same resource. And then to reduce load, to enhance scalability, cost efficiency, and to increase availability. Then caching backends. So there are a variety of caching systems you can use on your API, depending on cost, the speeds you want to achieve. Do you want a self-hosted service, that's where you deploy it yourself, manage updates and backups yourself, or do you want a managed service? Or are you looking for a distributed system where your cache is on different regions, or do you want just a single node caching system? So the first one I'll talk about is database. I know this might come as a bit of a surprise because we said caching is storing something in a fast temporary access storage layer. But the reason why I included database in this is because it's probably the easiest way for you to start caching on your APIs. You probably already have a database that serves data, and instead of thinking of looking for a new caching system, you can just use your database. So it's very cheap, and then in that case, you just create a table with a key, value, and expiration columns. So, for example, let's say you have a query that joins a couple of tables and takes time to load. When you have a cache table on your database, instead of pulling data from all these different tables, it will just take from the cache table, making retrieval very fast. And then Redis is probably the most popular caching system. I know most of you have heard of Redis, and it's for good reason. It's super fast. It has a ton of features. It has advanced data structures. It has snapshots, replications, etc. And then finally, Memcached. Memcached is free, open source, high performance, but it has a way simpler API compared to Redis. So unlike the different features that Redis will offer you, Memcache is just a simple old store and then retrieve. And then while hosting your cache, there's a couple of things to consider. The first is that a database cache is probably the simplest to host. You can just co-locate it with your main database, no extra setup. But if you want a managed caching service, which I feel most people here would want because you're just back-ended writing an API, you don't want to manage different services. So in that case, you can, a couple of options to consider is AWS Elastic Cache, Google Cloud Memory Store, Azure Cache for Redis, and Redis Enterprise Cloud. And then a bit of caution with Elastic Cache is, as everyone will know, AWS can surprise you with bills at any time. But while using Elastic Cache, I want you to be extra aware on how you deploy Elastic Cache so that you don't incur costs that are not needed. And then a very cost-effective alternative that I've used and enjoyed is Upstash Redis. They give you up to 500,000 commands free and some other beneficial services. Now, let's go into the caching strategies. So I outlined 5, I think, most common caching strategies you see in production. Well, one disclaimer, by the way, is that there's no silver bullet. There's no one caching strategy that rules them all. Each of them has scenarios where they shine, and depending on the kind of application you're building or API you're building, you can now say, okay, this is the caching strategy for me. So the first one is the cache aside or the lazy loading pattern. So in that case, when a request is made to your API, it first of all checks the cache, and then if there's no resource for that entry, fetches from your database, populates the cache, and then serves it to the user. And a pro of this approach is that you can be sure that only data that is actually requested is in the cache. But a con is that if there's suddenly a lot of requests for the same data, it can cause a database spike. So it's not bad, but it's just things you should be aware of. And then the second one is read-through caching. And it's probably my favorite type of caching. So in that scenario, it kind of takes what the cache aside pattern is doing. But in this case, you now have a separate cache layer that handles all the cache management for your app. So it will handle fetching data from the cache and also invalidation. Because when a post, put, delete request happens, you have to clear what's in the cache so that you don't serve stale data to the client. And then we have write-through caching. In that scenario, you write both to the cache and to the database anytime you store a resource. So what benefits this provides is that the cache is always consistent. There's never a chance where the user will see stale data, but this now increases your write latency because for every post request, it will write to the cache and write to the database synchronously. And then we have the write around caching. So this is kind of like a walk around to write through. So in write around, what it does is it writes to the database first and then updates the cache when that resource is requested. So this kind of fixes some of the problems of write through. And then the final one I'll be talking about is stale while revalidate. So in stale while revalidate, when a request is made, it will serve expired content and then be updating the cache in the background. I think it's mostly used in, I don't know if you use Google services a lot. If you update, let's say, your profile picture on Google, it doesn't update instantly on Gmail. You'll see that there's a couple of delay. Microsoft ecosystem also has that. There's a couple of delay before you now see that, oh, my new profile picture is here. So that's part of stale while revalidate. So instead of, profile picture is probably not that important. So I think this will be used where a situation where accuracy is not that important. So just serve them the old profile picture and later we can now revalidate. Okay, so thank you for listening. Are there any questions? Try and talk. I think I can hear.
Okay, so I have like two questions.
Okay.
The first question is when you do the catching on the front side,
Okay. Thank you.
when you're doing the catching on the back end side, is it advisable to also do the catching on the front end side too? Because when you're doing catching system on the front end side, you have to also invalidate when you're doing mutation on the front end side. So the time response between the back end to the front end. But is it advisable to tell your front end to also do the catching on the front end side? And the second question I want to ask.
No, let's start with the first one. So what kind of caching are you doing on the front end? So I asked, what kind of caching are you doing on the front end?
So you're making a GET request.
Okay.
Let's say you're pulling data of list of 100 users.
Mm-hmm.
So you can catch those data, and also so that when you want to mutate those data, you just look for the one that you mutate in and invalidates that catch. So that's for front end side. So when you're doing the back end side, you can also use Redis to store data that are coming from the back end side, right?
I think unless you want a super real-time system,
Yes.
the cache on your backend is probably enough. But if you want to still go further and say, because the round trip from the API will probably take too long.
Yeah.
So I think unless you want a super real-time system, your backend cache is enough. But if you want something faster speeds, then you can say, okay, let's also cache this JSON on the front end as well.
So you can still do both.
Yeah, you can do both.
Okay.
Okay, so what's your second question?
So the second question is, when you want to do a caching system, you talk about database, right?
Okay, yes.
Database. So what is the step for using Postgres for your caching system on your database?
Okay, so using Postgres as a caching system is as simple as having an SQL table with key, value, and expiration, and then you probably have maybe a cron to like delete old cache records eventually, right? So it's just as simple as having that SQL table. Any other questions?
Great talk. My question is this. Oh, okay. So when you're implementing a caching strategy, right? If you work with an ORM, object
Okay.
relational mapper, they allow you to sort of have caching on the database level. I've never really understood how it works, but I know that it's totally different from caching after the request as it's your server, like from your API, say your
Yes,
controller
yes.
level, API gateway level.
Yes.
So I'm wondering if you have any experience with caching very close to the database that ORMs typically support, and if you would advise against it.
No, I don't think it's bad, but it's probably not as fast as if you had Redis. But I don't know the ORM you're using, but if it's Eloquent, they have a Laravel basically. So they have this cache remember. So that one, depending on the cache driver you support, it can store your database or it can store on Redis or anywhere. So it's not a bad idea, especially for a start. It's good. Any other questions? Okay, I think that's all. So thank you so much for having me. Enjoy the rest of API Conf.